So, before we get going with anything, I want you to take a minute, and I'm on page, whatever number this happens to be. 15. Thank you very much for that. Take a minute. In your own words, what is the mean value theorem? If one of these kids in Ohio comes up to you and says, I remember you from calculus class. What do you remember about the mean value theorem? Write that down, please.
Bless you.
Thank you.
You're welcome.
I like that. Okay, I'm seeing stuff that I like. I'm seeing some stuff that I don't like. Oh, I definitely don't like blank page. Don't like that at all. Okay. So hopefully you've got something about the conditions. The condition is that f is continuous on AB, those are closed brackets, and f is differentiable on the open interval AB. These are the conditions. If you didn't write f is differentiable on AB, another way to write this would be to say f prime exists on AB. Those are the conditions. What are you promised? What's the guarantee? What does the MVT guarantee us? The derivative is equal to the slope of the secant line connecting the endpoints. Maybe you use the words that way. I would hope you'd write something like f prime of c. Wow, this marker's got to go. It was doing so well. F prime of c is equal to f of b minus f of a over b minus a. The f of b minus f of a over b minus a, you guys know that this is slope of secant. This guy over here is slope of tangent. There will always be a place in the interval where the tangent line has the same slope as the secant line. Everybody okay? Mm-hmm. There's one thing about the value of c that's really important, is that c is inside the interval. C is in between a and b. It's not an endpoint. Everybody okay? This is an existence theorem. There is always going to be at least one place where this is true. That means it could be more than one place where this is true, but there's at least one all the time, as long as you have continuous on a closed interval, differentiable on an open interval. And I think we're in a good place from here. So here's the plan for the next 20 minutes. We've got the cups. If we can get the cups out. There are 5 multiple choice questions. All of these have shown up on past AP exams. Or, oh no, I took the cups with me to North Side. Oh no, only 2 groups have the cups. Okay, never mind the cups. We're still going to go on. The cups are not going to get in my way. Okay, in your groups, you're going to get 2 minutes per question. You have to come up with a unanimous answer within your group. Delia, Ashley, Kaylin, you have to agree on your answer. You've got 2 minutes. Question number 1. Get going. See what you can do. Pedro was on fire yesterday. I would listen to Pedro today. Unless he gets the first one wrong, in which case we stop listening to him. Bro, I thought you called him Boo. Abraham, I would get you out of that relationship if he was calling you Boo.
I treat him right.
Well, then you can stay in that relationship.
So we have to like.
Yeah. It's that word.
Is it A minus B or is it B minus B? B minus A. Like this one?
But as long as you're consistent, if you, for some crazy reason, you do f of a minus f of b, be consistent, a minus b in the denominator. We've got about 40 seconds left. You have to lock in your answer as a team. Jose, what's going on? You guys are a team. Get in there. Fight your way in.
I was supposed to know that.
What's that?
And there is a point because it's
Yes, you can.
I guess
Yeah, you can.
but
It's more of a team instead of I'm more close to the
All right, friends. Let's lock it in. The figure to the left shows the graph of a differentiable function f. Which of the following could be the x-coordinate of point at which the line tangent to the graph is parallel to the secant line? Parallel, you guys all know, means same slope. So most people I saw, they did this. They're like, okay, here's my secant line. Where is the tangent line parallel to the secant line? I saw some people who took out a ruler and they just said, okay, let me kind of like shift it up or maybe shift it down. How many guys did that? You did it with a ruler, you did it with a pen, you did it with something to kind of visually see it. Okay, so here's your secant line, and if I shift it up right here, my tangent line is parallel to the secant line. Anywhere else? If I shift my line down, my tangent line is also parallel to the secant line. So I have two places where the tangent line and the secant line are parallel. And that's okay. But only one of them is actually a labeled point on the graph. So if all goes well, you went with C. How many guys honestly had C? 1, 2, 3, 4, 6. Okay, most groups had it. I want to check in with these two groups that didn't get it. Problem number 2, 2 minutes, see what you can do. Okay, first, what went wrong? Nothing went wrong?
I feel like we try to work together.
Well, because I heard at one point you guys say, but like, what is the slope? Right, you don't know what the endpoints are, you couldn't find the number. In this case, it wasn't about finding the number, it was about just finding the place. Visually or okay.
So it's because
we do the
The difference between
a portion of the graph shows the differential function f is shown the value of c equals 3
the tangent line actually does have the right slope.
plus f on the
But if I slide it down, the place where my tangent line has the right slope,
as well as the slope of the line
not like a label point, but it's like
Negative. Where do you get
the fact that there's 2 points where this happens is that's fine, that's good. But it wasn't Careful, Carlos.
so what do you
what do you
Just careful.
what do you do?
Carefully you broke. Carefully you broke.
Where are you referring to?
What? No,
Because
Liking what I'm seeing so far.
yeah.
Plus minus.
Don't always.
Wait, plus minus.
Negative 8.
Exactly, I thought you were talking about negative 8.
Hey man, slow down. It's
4, 6.
all gonna be okay.
This would be 10.
Alrighty.
I mean, 5.
Alright, a portion of the graph of a differentiable function f is shown on the left. Okay, the value of c equals 3 satisfies the conclusion of the MPT. The conclusion of the MPT, that's just this f prime of c equals f of b minus f of a over b minus a. On the interval negative 2, 8, I saw just about everybody said okay. Now he's talking about that secant line. They found the slope. They said f of 8 minus f of negative 2 over 8 minus negative 2. What is that? Negative 3 minus 5 over 10. Negative 8 over 10, so negative 4 over 5. All the friends are okay?
Yes.
Good. So everybody picked C.
Yes.
These are the two questions that I think are kind mean value theorem questions. If there was going to be a whole test on the mean value theorem, these are the questions I'd expect almost everybody to get right. It's time for the push now. Okay? Thank you, Jose. Okay, so I want to see what you guys do. Pay attention to the conditions needed for the mean value theorem. Also, these questions, number 3, comes from the master math mentor. His name is Stu Schwartz. I put this question on last year's unit test, and only 14% of students got it right. Now, let's have some real talk here. If 1,000 monkeys entered the room right now, and 1,000 monkeys randomly selected an answer to this question without knowing anything at all, what percent of them should get the question right? Look at the number of answer choices here. 1/5, what percent? 1/5, yeah, somebody said 25, that was Jose. Okay, we would expect 1,000 monkeys roll into the room, 20% of them are going to get this right knowing nothing at all. Last year's class, only 14% got it right. They were beaten by the monkeys. Don't get beaten by the monkeys. There is something sneaky in this question. Be on the lookout. You got 2 minutes. I will open the door and let the monkeys in. It'll be confusing because we're going to want to call them all Juan, but you know. Not this one. No. I'm scared of this
But on here it says A less than
Isn't it ABC? Oh, ACD.
but it doesn't equal to.
Oh, yeah. I don't think that matters, does it?
I just bit my
I can hear those monkeys coming for us.
A less than C less than 4 and which they're all.
because I mean, because it's supposed to be endpoints, they're not supposed to be.
It can go. It can equal to here, but it can't. It can't equal.
So then what do you put?
It's supposed to be a
It's open value. It will never touch open. You see how it
So you
says less
can
than
use those to get your point?
All those monkeys are going.
See, so this is a function. There's two because
we're just being
so it can be 0 because there's a cosine in the middle.
yeah. It can be 0.
So it's not.
It can be 2 or 0.
Yeah.
So we're just
Wait, why not 2?
because it's also that's the one.
No, it starts at the cosine, so it wouldn't show up on the graph. Which is the point. And then the other point. It can't be negative 4 because there's 2 cosines. It can't be 0 because there's a cosine in the middle. So it's not different from
Oh, you're saying that you're saying from the two it would just show like this. It wouldn't show
Yeah,
that there's
it's
no
just the second, it's not the plus point.
Alright. Pedro, I just need to, whatever it is that's happening in your morning routine, we need more of it. We all, you need to like, get a YouTube channel and see what you're doing in the morning. Okay, here we go. So continuous function f is defined in the closed interval -4 to 4. The graph of the function f shown to the left consists of a line segment and two curves. There is a value of a, where a is somewhere between -4 and 4, for which the mean value theorem applied to the interval a, 4 guarantees a value of c such that f prime of c is equal to 3. And the options are -4, 0, and 2. If a is -4, we're all the way over here, and I look on the interval -4 to 4, the question is, does there have to be a place where the derivative is equal to 3? Does there have to be a place? Now, what I saw a lot of people do, they said, okay, let me find f of 4 minus f of -4 over 4 minus -4. And if you actually do that computation, you get 3. But why can we not use -4?
not in the closed interval.
That's not the problem. What theorem do they want you to use? The mean value theorem. To use the mean value theorem, two things better be true. The function has to be continuous on the closed interval, and the second piece? Differentiable on the open interval. Can I use the mean value theorem on this interval -4 to 4?
No.
Pedro, why can't I use the mean value theorem on this interval -4 to 4?
It's not differentiable everywhere.
The graph's not differentiable everywhere. Where specifically is this graph not differentiable?
2 constants and 0.
Okay, not differentiable here because you have a cusp point, and not differentiable here because you have another cusp point. So you can't use the mean value theorem starting at -4 because you have cusp points in between. Nice. Now what if you start at a equals 0? If I start over here at a equals 0, I no longer have to worry about this cusp point, but I still have one in between. I can't start at a equals 0. If, however, I move that line all the way over to a equals 2, do I have a continuous function?
Yes.
Do I have a differentiable function?
Yes.
And does the slope work out to be the right?
Yes.
Absolutely. If you find the slope, you're going to find that secant is equal to 3, and so that would get us
C.
option C. Again, how many guys honestly had C? Okay, 1, 2, 3, 4, 5. 5 out of 2, 6, 9, 12, 5 out of 15 is 33%. Congratulations. You beat the monkeys. Not by much. But you beat some monkeys. So we're ready for the next time the monkeys roll in. Carlos is always ready. All right, number 4. See what you can do. Another 2 minutes with your partner.
Let f be a function that is differentiable on the open interval 1 to 10. If f of 2 equals -5, f of 5 equals 5, and f of 9 equals -5, which of the following must be true?
So it can't be.
It's 2.
It can't be. The graph of f.
Left.
Thank you.
No, because remember anything about our derivatives? Remember that if it has a 0, that means that this f had a horizontal tangent line. So that means it has at least 1. So it's 2.
That's the 1.
I'm saying it has to be.
So it can't be 2.
Oh, wait, you guys have to have 2.
So that's what?
Yeah.
So
Okay, let's get it.
just you need to.
It goes from -5.
Yeah.
At least.
Evelyn's got some good strategy.
This is F.
It's does have an
But still, because it goes from, oh, no, never mind. Yeah, yeah.
Roberto's got some good strategy.
So,
Delia's got a good strategy.
that means it can be.
If you haven't done this yet, I'd strongly recommend plotting the points.
For some,
2, -5. 5, 5.
Let's talk about F.
Yeah, but
9,
that's if it's
-5.
decreasing and back increasing, that means that F is
so
also
this is
decreasing and
my some
decreasing.
point
So this shit has
that
So who knows, right?
All right, friends, so I can put everybody back
So
together.
we just need to determine some of these, right?
How many of you guys actually plotted the points?
That would be true.
It is such a good idea to plot the points, but you want to be careful when you do this. All right, let f be a function that is differentiable on the open interval. Okay, you guys know that that means derivative exists. No issues there, so nice and smooth. F of 2 equals -5, f of 5 equals 5, f of 9 equals -5, which of the following must be true? Statement number 1, f has at least 2 zeros. This is true.
Yeah.
Why? Why? What theorem says this has to be true? There is a theorem that we know, the intermediate value theorem, the IVT. But here's where you got to be careful. If you want to use the IVT, you need to know something about the function. Is the function continuous?
Yes.
But now wait, I don't see any mention of continuity ever. But the function does, it is known to be differentiable. And if you have differentiability, then you must also have continuity. Okay? So you want to think, is there any way to get from here to here to here without having at least 2 zeros? Right? Any way that you draw it, even if you're like, 2 zeros, so statement number 1 has to be true. That's the IVT. Number 2, the graph of f has at least one horizontal tangent line. Now, last class, a lot of people said true, and they said, oh, it has to be up here at 5, 5, because that's the highest point. You don't know where, but I know that if I connect these endpoints, what's the slope of the secant line? The slope of the secant line is equal to 0. So no matter how I draw my function, there has to be some place where I have a horizontal tangent line. That's true. Yeah, you want to stick with secant line. And last, is there some place between 2 and 5 where f of c is equal to 3? Right? That's another IVT. Here's at 2, -5, up here at 5, 5. There has to be a place where the y value is equal to 3. And that's your IVT. So that's E. How many guys honestly hit E?
I was getting there.
You're getting it. Okay. I think we're in a good place. We can turn the camera off tonight. Get L'Hopital's rule done. Get all those test corrections done. I have a new assignment for you tomorrow.